Okay, great. So this is PyCharm. What you see on the screen is PyCharm. This is another popular IDE, but doesn't matter whether you're using Colab or PyCharm or VS Code or any of those editors, doesn't really matter. Okay, so we know the purpose of doing programming, right? We want to connect with computer. We want computer to work for us, and that's why we are using programming language. The instructions that we're going to write will be translated or will be converted to the commands which computer understands, right? And the translator, okay, which converts our English commands to say the machine level language is called programming. So Python is basically a translator. Okay, if I say print, okay, and just for information, Python is case sensitive language. That means you write print all small or lowercase or uppercase, they mean different things, right? So it's a case sensitive, whereas SQL that we'll do later is case insensitive. So, commands there doesn't matter which case we use. So when I say print here and I say hello, okay, and when I click on run, okay, so PyCharm has its own way of running it. So you need to select the file name and then right click on it and say run file name. Okay, and you can see the output right below here. So when I say print hello, Python, okay, takes this English characters, converts into machine level character, okay, executes on the computer, gets back the result and translate back into English for us. Okay, so that's why we call um, this programming languages as interpreter or compiler. Now, if we talk about C, C++, Java, these are all compiler based languages. Your Python, R, these are interpreter based language. So they translate each line. So they translate line by line. They don't take whole code at once like C or C++ or Java. They take line by line. That's the only difference, and both has their own advantage and disadvantages. But obviously, that's not the topic for discussion. Okay, we'll see how to use Python, and we all know, right, why Python, because Python kind of has become one of the most popular language recently because of its easy syntax, the easy way of writing. Syntax basically means grammar for programming languages. For our natural languages, English or for that matter any language, French, Spanish, you have those grammars, right? Which sets the rule for programming, for speaking language. Similarly, syntax is kind of rules that we need to follow when we do computer programming. So the first syntax we're going to learn is about this. Okay, so what you see here, print. Okay, now print is called function. Okay, by the way, you see this hash, these are comments. Okay, that means when you put hash and you put any text after that, it means that you are saying to Python that ignore, these are not for you. Okay, we call them as comments, and these are for human beings, for us. For us. So, maybe I want to put a comment for myself. I do a programming today and I might forget after a week what I did, what logic I used. So these comments are useful. Obviously, your code will not be just your code. Actually, when you set work in a company environment, right? You'll have other colleagues who will work with your code. So they might find it difficult to work with your code. So comments will help them to understand what approach you followed, why did you program in a particular way, right? So comments are great, though these are ignored by computers, but these are very helpful. So hash and anything that you follow here will be ignored by Python. Python will not read, or for that matter, any programming language, they will ignore the comments. That those are not for computer to understand. These are only for us. So whenever I want to tell you something, I'll put a comment and I'll type it here so that you see it on the screen as well. Okay, so coming back to our discussion here, we have used print. Print is called function. Okay, and what does function mean? Function means that it's a It's actually a block of code to be, to understand it in a very crude manner. But what does it mean is that they are set to do certain tasks for us. Okay, so functions are written or designed to perform certain task. Now, what is the task here? Print, okay, is used to print whatever you pass to it onto the screen. So I'm passing hello to this, so it prints hello on the screen. Okay, so always, okay, this is syntax. Okay, syntax of function is that function is always followed with these two, pair of simple bracket. Okay, so if you have to write print, you say print all small, okay, all lower cases, no uppercase, okay, and then you give simple bracket open and close. Okay, this is how we write a function. Okay, and if I want to pass a value to a function, I'll put it within this parenthesis. Okay, within this parenthesis, I'll put whatever I want to display. So you can display two things here. One, you want Python to evaluate and display the output onto the screen, or you say, okay, I don't care, just take this and display this onto the screen. So when you want print to just display what you want it to display, okay, this quotation is used. Okay, it doesn't matter whether you use single or double. Python accepts both as it is. So I can say, how are you today? Okay, and when you run it, it's going to display as it is, okay, because we gave them in a quotation, pair of quotation here. Okay, it doesn't really matter whether you give them within single or double, it doesn't matter. Now, if I want Python to use its brain and evaluate the output for us, then we don't use quotation. For example, if I say print 5 plus 4, now I'm not using quotation here. So when I don't use quotation, it means I'm asking Python to add these two numbers and display the output for us. So 5 plus 4, 9. Okay, so it actually gave us, it evaluated and gave us the final answer. Okay, but if I put same thing, okay, I'm going to copy this, select this line, and I say 5 plus 4 in quotation. And when I run it again, okay, you see, it is going to print as it is. So quotation means as it is. Okay, you can give junk, you'll get junk onto the screen. Okay, when you don't put quotation, it means you're asking Python to evaluate it. Okay, so it will evaluate and give you the answer. Okay, evaluated answer onto the screen. That's how print works. Now, you can actually use print with a combination of quoted text, unquoted text. Quoted text and the expression rather. So let's say if I print something like this, I say 5 plus 4 equal to, and then I go and I say comma. Comma will separate two set of values. Okay, two different set of values in functions language, we call them as parameters. Okay, so these are two different parameters or two different set of values. So when you have to give, so print can accept multiple parameters. Okay, you can keep on giving parameter 1 comma parameter 2 comma parameter 3 comma so on. So parameter could be your quoted text, or it could be your value that you want to, or expression that you want to evaluate. Okay, so when I run it here, this one, so you see 5 plus 4 equal to, since this is inside the quotation, you get as it is. Because we have used comma, okay, you'll have a blank space. So comma will print a blank space here. And that is followed by your evaluation, or what you call the evaluated version of 5 plus 4, 9. Okay, and again, we can give something like this, let's say, and 6 plus 4 equal to comma 6 plus 4. You can go on adding different parameters to this, and print will display it on the screen for you. So far, is it good?
This is good. I think we understand that part.
Yes, it is.
Perfect. Thank you. So I do need feedback initially, couple of days, because we are new to each other, right? So, so such feedback. And if you can stop me if you don't understand, if you want me to explain more, just stop me there. Okay. Great. Okay. So this is how print works. And of course, we'll talk about more such examples today and tomorrow. But now let's turn our attention towards something called as variables. Okay. I'm sure you must have used variables in other programming languages as well. So what is variable? Now see, I've been using values here, 5 plus 4. Now, instead of using 5 plus 4, okay, let's say I want to use now 15 plus 9, something else. But since you have used the constant value, we can't change. We can't say, let's assume 5 is 15. We can't assume 5 to be 15. 5 is 5, 15 is 15. So instead, what we can do is we can create variables. As the name suggests, these are variable in nature, in the sense it can store value 5 or it can store value 15. Whatever you assign will be assigned to it. Okay, so variable, okay, is represent something like this. Now, if you see the way you write variable or the function, it is difficult to differentiate between them. The only way you can differentiate between a variable and a function is variable will not have pair of parentheses, right? But functions will always be followed by parentheses. So print, if I had not written this, we could have said print equal to 6. We could have used print as variable, but we want to use print as a function. So you put parenthesis. And of course, inside this, you can add as many parameters as you want to. Okay. So coming back to our discussion on variable. Okay. So PyCharm and even Colab has this line numbers, isn't it? So if you see line number 6, the value of var1 is a variable name, and you can name anything. Okay. But there are a couple of rules that you need to keep in mind when you are naming variable. Naming rule. Okay. It shouldn't start with a number. I cannot say one var. Var1 is fine, but one var would throw error. Okay. You cannot start a variable name with a number. And apart from alphabets and numbers, it can only have underscore. So only underscore is a allowed special character. Okay, so I can say var1 underscore 1, totally fine. Okay, this is also fine. This is also legal. But I cannot say var1 hyphen 1. Okay, Python will not accept. Colab or PyCharm will immediately throw you error. It'll show you the red underline. Okay, indicating that there is error. Okay, there's something wrong here. So apart from A to Z and 0 to 9, only underscore is allowed while naming a variable. So you don't name using hyphen or and or anything else. Just use underscore. So I'm saying var1 equal to 5. Again, if you come from other programming languages like C, C++, Java, you'll find it a little difficult here to understand. But those who learn Python for the first time directly, first language that they learn is Python, for them it's easy to understand. You say var1 equal to 5, it means var1 is 5. But again, in other languages, first we need to define the data type, right? We have to say int var1, and then you say that var1 equal to 5. You cannot assign a value directly to a variable. But in Python, okay, the values can be assigned directly. And the Data type is implicit. So now we are talking about data type is implicit. Let me finish this part. Don't finish this statement. Is implicit. Okay. Now I'm talking about third concept of the day. So we are saying print. Print is a function. That's the first thing that we learn. Then we spoke about variables. Okay. Variables are used to store values. So here in line number 6, var1 has 5, and line number 9, same var1 has become 15. Right. So if I print here, if I say print var underscore 1 plus 10, you should get 15. And if I do same thing here in line number 10, you should get 25, right? 15 and 25, right? Okay. The third concept, as I said, is data type. Now, data type is important, okay, for any programming language because that dictates what options or what different options, okay, or properties that a data can have. Okay, so let me explain again. So if I say that take two numbers, right? If I tell you take two numbers. So now when I say two numbers, you'll start thinking of mathematics, right? You can add them, subtract them, multiply them, right? You can do power or whatever, right? But you cannot do something which is like you can't write a story, right? To write a story, you need words, you need text, right? You can't write a poem or story on numbers. So numbers, when you say, you set aside certain properties for numbers, right? But if I give you a dictionary of text, then you'll have different set of then you don't think of multiplication of two text. You start thinking framing a sentence based on those text, isn't it? So that's why data type is important to understand because that dictates what options are available for the data. Okay, so in Python, okay, we have 5 types of data, okay, or data types. Okay, we call them as basic data type, basic data types. These are your int, which stands for integer. Okay, it means values, okay, that ranges from minus infinity to plus infinity, right? But without decimal part, that is the point part. So, minus 999, minus 99, 0 even, your 1, 2, 99. All these are examples of integer. Okay, so of course, when you think of data as an integer, we'll talk about operators, okay, in some time. So, you can add them, you can multiply them, you can divide them, etc. You can perform. The next data type is called float, okay, written as float itself. These are values or numeric values, okay, I would say numeric, a number, right? Numeric values. These are also numeric values with decimal part, right? So like minus 5.5, okay. Even 5.0 also is treated as float. Okay, it doesn't matter whether you have 0 in the float part, but if you have 0, it is treated as float. You can have 0.0, etc. Okay, whenever you have decimal point, it is the float value, right? So if I say 7 divided by 2, and if I take that output has to be an integer, you'll get only 3, isn't it? 7 by 2 is in fact 3.5, right? But if you want the output to be integer, then you lose the decimal part. Okay, you get only 3. But if you want float as output, it's going to be 3.5. So that's the importance of data types. Okay, and for next few days, right, we are going to talk about different types of data itself. right? How to handle integer, how to handle float, we'll learn now. Later, we'll see how to handle list, how to handle tuple dictionaries, okay? After that, we'll learn how to handle NumPy pandas when we get into machine learning, etc., right? So it's all about handling data, and each of these data actually represents our real world scenario, okay? If we have to mimic our real world scenario into programming language, we need to know what is the closest matching data type, right? If we have to deal with numbers, integer is of course the option, okay? So of course, when we start using it, it'll be more clear. So, okay, so there are 5 data types, okay? 5 basic data types. We have just discussed about 2. Let's talk about third one, which is called complex, written as complex. This is also numeric, okay? Numeric values that represent square root of -1. I'm sure, in your high school probably would have come across this. In mathematics, we write with iota, or, we say I, correct? But in Python, we write as J, okay? The same thing, okay? In your earlier grades, you would have studied that square root of -1 is not possible, right? You cannot. So square root of 1 is 1, but square root of minus negative numbers are not possible. But then in your higher grade, I don't know if you have done it now, but if you have not done it, probably a higher grade, you will see that square root of -1 is possible. We call them as imaginary numbers. Imaginary numbers. So you'll hear complex numbers or imaginary numbers. So we're not going to discuss much. We'll take one example and we'll leave it. This is used in very advanced level physics, or even for pure mathematics, you'd use it, but not for our work. We won't be using complex number for the kind of work that we'll be talking about, for the handling data or anything like that. We don't use complex there. So complex numbers are useful when you are doing pure mathematic kind of research, right? Or you're getting into advanced physics-based kind of research. That's where it is used. But we will see one example. We'll see how it looks like. So you have int, float, complex. These are 3 numeric. Then you have fourth one, which is called str, stands for string, and these are your text data. Okay, so any text data that you want to handle, it is of type str. Okay, and the 5th basic type, the last one, is called bool. Bool stands for Boolean. Okay, and it has just 2 values. Okay, you have true or false. Okay, it's like yes, no, right? True means yes, of course. And this is how it is written. T capital, rest in lowercase. So T capital, RUE in lower cases. Or if you have to write false, F capital and rest in lower cases. This is how if you type, this is how you use. That's when it becomes your Boolean type, right? If you don't write in this fashion, then it's not treated as Boolean. Okay. So far, is it good? Clear?
We got it. I think most of these we went over already, besides the complex numbers.
Okay.
The Boolean string. We have gone through before, so we understand those. Limited, but we do understand them.
Perfect. Great. Great. So, okay, what I'll do is I'll show you complex numbers, and then, okay, just I said complex number, we're not going to discuss much because anyway, we're not going to use it. And then I will straight away get into operators, different operations that we perform on each of these. Okay. So complex numbers, I just said it is represented with J. So now let's say if I use a variable called var1, and if I say 5J, right? So J is what we represent complex numbers. So you have 5J, okay? And if I need to know the type, which function to be used, if I need to know the data type of this variable, do you remember?
Is that?
If I if I need to know what type of data this variable has, so how do I get it? we have something called as type, correct? Have you done this before? Type will tell us what type of data this variable has. Okay, and when you print it, obviously you'll get it on screen. So I'm going to print it, and when you run it, see it says class complex, right? It says it's a complex type. Now, so j, I just said, is square root of -1. So if I say, okay, if I say print var1 into, sorry, not 8, into var1, what will I get? So var1,
You said var1, so 5J times 5J.
correct. And that would be 5 into 5 is 25, correct?
Yeah, 25,
And j into
25.
j is j square.
J squared. Yeah, 25J squared.
So you get 25j square. But then what would you say? J is square root of -1. So j square would be -1. So you'd get it as -25. Okay. So let's run it and see. See, you get -25. Okay. And since the original type of var1 is complex, the final answer has to be complex. Okay. You don't change the data structure. You don't change the data type. So what it has done is added 0j. 0 means 0, right? It means nothing. But just to indicate that it is complex, it has added 0j. So 5j square would be -25 plus 0j to indicate that it is still a complex number. -25 is integer, isn't it? So, it means that output is still a complex number itself, not an integer. So they add 0j. Okay, so we'll stop our discussion on complex here. Okay, it's a different discussions. Okay, maybe if required, we'll take it up later. Okay, now moving to different operations that we can perform, right? We talk about operations and operators. Operators and different operations that we can perform, right? So if you have numbers, you can perform what is called as arithmetic operators. Arithmetic operators or operations, right? So operators are your plus, minus, into, division, integer division, power, and modulus. I'm sure these four are very clear. Can you tell me what does double slash give us? It is called as integer division.
What
Double
is it called?
slash. Integer division. Integer division. So let's say if you have number 1 equal to 7 and number 2 equal to say 2. Okay, and if I print, if I say num1 divided by num2, okay, this is this division, right? So this one should give us 3.5, correct? But now if I take the same thing and I run, sorry, let me put it in next line. Okay, double slash. Okay, it will remove the decimal part and just give us the integer part. That's what is called integer division. Okay, it's called integer division because it will give us only the integer part, not the decimal part. Even if it is 3.9, also it will give us 3 only. Okay, it will trim the decimal part. Okay, so if you just want to get the integer value, okay, we use double slash integer. It's called integer division. And then single star is multiplication. What is double star? Double star is like, no, this is multiplication. This is,
I'm saying, so double, would it be integer multiplication?
sorry, I missed that. Double star would be what? Sorry.
Say, would it be integer multiplication?
No. Okay. So if your if your numbers are already integer, right? In this case, we're already integer. Even this would also be integer multiplication, right? Multiplication will not result into float or anything else. Division would result into float, right? But single multiplication would not result into a different type. So if it is, say, if you have 7.5 and 2.5 float, of course, output will be float. But if you have them as integer, this will also be integer. This is as exponential power. Okay. So if I say print num1 star star num2, okay, star star is like power. So this is 7 to the power 2, 7 square, which should be 49. Okay. If you make it 3, it will be 7 to the power 3, 7 cube. 7 cube is 7 into 7 into 7, 49 into 7. Okay, it will be 343. So double star will give us power. It's to the raise, right? When you have 3 and 7 and 3, it's like 7 to the power 3 or 7 cube. Okay, we multiply 7 3 times. Okay, so that's this. That's the double star. And modulus, okay, talks about remainder. So if you say 7, yeah, num1 percentage. Though we write percentage, okay, this is exactly percentage, but we call mod or modulus. Modulus or mod. In short, we call them as mod. Okay, we write as percentage sign. Okay, but we call it as mod. What it does is, so when you divide 7 by 3, okay, and we look for perfect divisibility. So 7 by 3, okay, it goes by 7 2 times, sorry, 3 2 times, 6. And you're left with 1 as remainder, isn't it? Okay, 7 minus 6, right? So now let's say if I use here 50 and modulo 6, what do you think you'll get answer as? So now if you look at 6 table, it is 6 8. 6 8 times is 48. Okay, 6 9 times we can't do it because then it goes beyond 50. 54, right? 54 is more. So you go 8 times. 6 into 8 is 48. So 50 minus 48, 2 is the remainder. So we are not looking at the decimal integer. We're looking at integer division and then whatever is left. Okay, integer division and whatever is left, that is your remainder. So 50 mod 6 will give us 2. Was I clear? If not, maybe I can show you in a different way. Let me try this way. Okay, we'll go back to our lower grades, elementary classes. So let's say we have 50 here, right? And we are trying to divide 50 by 6. So 6 5s are 30, then 6 into 6 is 36. 6 into 8 is 48, right? 6 into 8 is, so we write 8 here, right? And we say 48, correct? And you get 2. Right? This is your mod value, this is remainder. This is your integer division. Okay, this is your integer division and this is your modulo. Is it clear now?
Yes.
Awesome. Okay, so that's what we get here. So now if we go back to our PyCharm screen, let's switch back. So instead of number 1, if I say 50 and 6, so you expect here it to be 8, right? And this to be 2. Let's run it and see. So see, this is 8 and this is 2. So this is your remainder, okay? And this is your, we call it as quotient, right? But you understood, right, what it gives us? It gives us the integer part when you divide 50 by 6, no decimal part. And the decimal equivalent is remainder basically, right? So you get remainder here. So these are the basic arithmetic operators, the mathematical operators that we perform on these numbers. Next comes comparison operators, and these are important. Comparison operators and the Boolean or logical operators, we call them. These are very important because most of our logic that we're going to build later using loop and conditions will use these operators. So as the name suggests, let's do it. Let me write it here. It's called comparison operator, right? Comparison operators is to compare two values. Okay, so is it equal to? We write as double equal to. Is it greater than? So we write greater than. Is it greater than equal to? Greater than equal to. Is it less than? It's like asking question. Is it less than? Okay, so less than. Then less than equal to. Then not equal to. Right? So let's take two numbers, num1 equal to 10, num2 also equals to 10, and num3 equals to 15. Okay, let's try to see the usage of this. So I'm going to say print num1 equal to num2. So it's like asking question, is num1 equal to num2? So what do you think the answer would be here? Is num1 equal to num2?
Yes.
Yes. So that should be true, isn't it? So comparison operator will always result in bool values. Okay, true or false. Okay, there's no other option that a comparison operator will give you. They're equal or not equal. They're less than or not less than, greater than or not greater than, right? So when you run it, so you see they are equal, so you get true here. Now if I take same thing, okay, and instead of num2, this time I'll compare it with num3. Then what do you say? Are they equal? No, they're not equal. So you get false here. If I make it not equal, is num1 not equal to num3? That's what, right? Is num1 not equal to num3? And answer is true. Yes, num1 is not equal to num3. True. Okay. Similarly, you can try print num1 greater than equal to num2. Okay. And I'm going to do this again, greater than equal to. Now tell me, what do you think this line of 42 would give us?
Which line? 42. Num1 is
No,
greater than num2.
num1 is not greater than num2, right? So I'm asking, is it greater? Answer is
False.
false. Exactly. Okay. They're equal but not greater. Okay. So this is false, right? And what about here? Next one.
True.
Exactly. Okay. Num1 greater than or equal to. Either it has to be greater or equal to. Of course, it is not greater, but it is equal to num2. So now when you run it, you see this is true and this is false. Last one is true. Second last is false. Okay. Similarly, we can try for less than, and then we'll move to Boolean. We'll say less than and less than equal to. So is num1 less than num2? Obviously no, right? So you say false. Is num1 less than equal to num2? What do you think here?
So num1 less than equal to num2. That also will be true.
Exactly. Yes, it will be true, right? So either num1 has to be less. Of course, that is not true, but It can be equal to also, which is true, right? So yes. So these are called comparison operators. Equal to, greater than, equal to, less than, equal to, not equal to. And this will always give you answer in either true or false. Okay. No third possible values. Okay. The next one, okay, the next operator are called logical operators. So logical operators. Okay. Now, let's say, let me make a prediction. Okay. I said Argentina and Brazil will play in the soccer, World Cup. This was a prediction before the tournament. But actually what happened?
Argentina won.
No, but it was not Brazil, right? So it was Argentina and France actually played,
All right, got you.
right? Played in the finals. So tell me, is my prediction wrong or right?
False.
False, exactly. And if I had, let's say, my friend had made another prediction, let's say, prediction 2, this time he didn't use word and, he said Argentina or Brazil will play in the Soccer World Cup finals. Finals, okay? Final is important, right? Okay. So what do you think? Is this true or false? Second prediction.
Right.
Okay. This is true. Okay. When you say or, you're not committing on both. When you say, I will do this work or this work, I will do this or this, that means you are not committing for both. You are saying, I will do this or this. Okay. You're committing only for one of the two, right? You're not committing on two. When you say and, you're committing on all. If I say, I will do this and this before I go to college. When you say, if I do this and this before I go to college, that means you are taking responsibility for both the work, right? You have to finish it in order to be meeting your promise. Okay. So, sometimes we say, or I'll do this or this before I go to college. That means you are promising only one. Now, if you do it both, great. Okay. But you are not committing on both. You're committing on only one. Okay. And Argentina did play the finals, right? So this will turn out to be true. You're not committing on both the names. You're saying this or this. Okay. So this is called your logical operator, and an or. Okay. And an or are called logical operators. Okay. And to understand logical operators, we need to create what is called as truth table. Okay. So what it means is logical, let me write it here, are your and or. Okay. So okay, so this is and an or, and they work only on, okay, they work only on, okay, comparison operators. Okay, that means output has to be Boolean. They work on Boolean values and gives Boolean as result. So it just like your addition will take two integer as input and you will get integer only as output. So your logical will need only Boolean values as input, and output will also be Boolean only. Output will not be anything other than Boolean. Okay, so let's talk about AND for a minute rather, right? So and if you say true and true, okay, you get true. Rest everything will be false. So false and false is same as false. I'll put F capital because that's how Python writes. False and true, same as true and false, which is false only. This is called AND table, and we call them as truth table. Okay. If you make both the statements true, if I say Brazil and France, only then your statement is true. Okay, otherwise it's false. If I say Brazil and Spain will play, Brazil is also false, Spain is also false, it will result into false. Okay, if I say Argentina and Brazil, Argentina is true but Brazil is false, so this is like this situation, true and false, Argentina and Brazil, false. Okay, false and true. So you say Spain and France will play. Spain is false. So this will result into false. And both false also, if you make, it is false, right? Like I say, Spain and Brazil will play. Both are false. So it is false. Correct? So entire thing, okay, will be false even if one value is false. Okay? Both has to be true to be true. Otherwise, even one value is false, it is false. Okay. Now we'll talk about the truth table for OR. These are the two main operators that we use. So OR, true or true, okay, is true. Okay. So what will happen is, let me put this here and I will take this here. Okay, let me add it. Let me change it to OR. So false or false will be false, and everything else will be true. So true or true is same as false or true, is same as true or false, is same as true. Okay, so even if one value is true, entire thing would be true in case of OR. In case of AND, even if one value is false, entire thing would be false. Okay, and when you have both AND and OR in a statement, when you have both AND and OR in a statement, AND is given higher priority. AND is evaluated first, then OR. Okay, let me take an example here. So I'm saying A equal to 5. Okay, in Python you can write something like this: A and B equal to 5, 10, right? And let me add C also. So C equal to 5, 10, 10. Okay, so A is 5, B is 10, and C is 10. That's how the values will break into different variables here, right? Okay, now let's say I'm not going to run it, but let's say I write something like this: A greater than B and B less than C and C equal to A or C equal to B or A greater than C and C less than A and B equal to B and C less than A or C equal to B. Okay. Let's say I have this equation. Okay. And if you understand this, then logical operators is understood. Okay, let's try to evaluate step by step. First, we'll convert the comparison operators into Boolean value. Okay, A greater than B, is it true or false? Right, A is 5, B is 10. 5 is not greater than 10. So it is F. Let me write F for false. Okay, now B less than C. B is 10, C is 10, right? B is not less than C. They are equal, not less. So this is also false. C equal to A. C is 10 and A is 5. They are not equal, false. C equal to B. C equal to, yes, both are 10. So this is true. Then A greater than C. Is A greater than C? No, this is also false. C less than A. Is C less than A? No, C is more than A. So this is also false. Is B equal to B? Yes, B is equal to B, true. Is C less than A? C is not less than A. This is also false. Is C equal to B? Yes, they are. So it is true. So what's first step is we converted comparison operators. We evaluated, not converted, we evaluated, right? We evaluated and we got the answer. Now our equation has both AND and OR. So we said that when you have both AND and OR, it is AND that needs to be evaluated first. Okay, before I do this, can I ask you a question here? What is 2 plus 4 into 3? What is this equal to?
24.
We'll wait for Dior. What do you think, Dior? Or was it Dior? Sorry.
DR.
Okay. So you're right. Okay. When you have both plus and multiplication, addition and multiplication, we first perform multiplication, right? So this is, okay. So in this first, you'll perform 4 into 3, 12. Okay. No, you got it wrong. 4 into 3 is
I
12.
said no, I said, wait. Oh, yeah, you're right. It's 14. Order of
Four,
operations, 14.
yes, yes, yes. So it is 14, right? So first you perform multiplication, then you add. So you get 14, exactly. So same way, when you have AND and OR together, first we need to perform AND and then we perform OR. So let's perform all AND first. F and F, F. F and F, F. Okay, so OR leave it. Again, F and F, F. Okay, and F and T, what is F and T? False and true?
C is F. F.
Yes, yes. In, F, both has to be true. Okay, otherwise all the other condition is false, correct. Now again you have F and F. So this is also false. So we are done evaluating all and now let's evaluate OR. F for T?
Oh.
Yes. T or F? T or F? T. T or T? Obviously T, right? So now let's evaluate this. It should be true. Okay, it is true. Right? Is it clear? No, this one example will clear all your doubts of comparison operators as well as the logical operators. Okay. So we have reached an important milestone. Okay. The basic, this is what basic is. Okay. Now we still have some time. Is it okay if we continue for another 10 minutes?
That's fine with me. Dior, you good?
Yeah, that's fine.
Okay, awesome. So let's continue. Okay, so so these are basic. Okay, and next we're going to build different logic, and all these that we have discussed so far actually forms the part of that. Okay, it kind of is the foundation for those things. Okay. So the first thing that we're going to talk about, okay, is called conditions. Okay, what is a condition? Condition, okay, is okay. So before I get into that, see, so far we've been executing each line, right? Okay, if you run it, you get line number 1, then 2, then 3, so on, and it goes sequentially one by one till line number 62, 63 that we have. Okay. But sometimes you want to control the flow of execution. You want to control the flow of the program. You don't want, okay, the sequential execution. Okay. So for example, okay, for example, you talk about assigning grades to students of a class. Okay, and you can have grades from A to E. Let's say you have grade A, B, C, D, E. Now you cannot say print grade A, grade B, grade E, right? You have to check for some condition. Based on condition itself, okay, you have to decide whether it is grade A or something else. Okay, so okay, let me take this example. I want to check, okay, I want to check if a number is positive or not. I want to check if a number is positive or not. Then what logic can I use? So I can compare it with 0. Okay, I can compare it with 0. Okay, so okay, let me go back to Paint. Okay. Okay, so you have value n. Let's say n equal to 50, whatever. Now you're checking here. Okay, is n equal to or okay, no, not equal to. Our intention is to check if number is greater than 0 or not, right? Or positive or not, right? I want to check if the number is positive or not. So I'll say is n greater than 0. So I want to use comparison operator. Okay, comparison operator is your n greater than 0. If it is greater than 0, that's when it is positive, isn't it? So this situation where you are checking for a specific condition, and based on that, you're going to make a decision. So you're performing a check, and based on that, you are making a decision, right? So it can be, it could be yes, or it could be no, right? If it is no, then you say, sorry, number is not positive. Or here you say, okay, whatever, right? Here it is yes. Is n greater than 0? Yes. So you do whatever you want to do when n is greater than 0. This is no, n is not greater than 0. So when you say it is not greater, it could be equal to or less than. Both conditions possible, right? So this is what we implement using if block. Okay, so we'll go back to our program. Okay, now one more thing you have to remember here is all our programs that we've been doing is from the beginning. Even if you give one space here, right, you will get error. It has to start from very first position. Now later you can give space, doesn't matter. Here you can give space, doesn't matter. Okay, still our program will work fine. Okay, but the first character has to start from position 0 or very beginning. Okay, so that's one. Now talking about conditions, okay, So I want to check if this number, let's say I define a number here, and num1 equal to 50. Let's say this is 50. I want to check if number is positive or not. Okay, so this is how you define that, the condition that we discussed, right? The rhombus, where we are checking, and then we are taking two different paths, yes or no. We'll implement that here. So I have to say if num1, okay, greater than 0. So see this. If, okay, is an operator to check if a number is greater, to check a condition, okay? So every time anytime you want to check a condition, you have to start with if. If this is this, then do this, otherwise do this, right? That's how, you have to remember. So if followed by your comparison operator, you are comparing, okay? And this, why we are saying comparison? Because the if works only on if it is true or false, nothing else. Okay, so whatever you put, we call it as condition. So if condition followed by colon. So condition is your comparison operator. It should result into either true or false. Okay, if it says true, you will go inside if. And if it says false, you will not go inside if. Okay, so what is inside? Okay, what is inside if? Okay, so after putting colon, you hit enter. Okay, you hit enter, what happened? Okay, PyCharm is intelligent enough, so it has given us that extra space, indentation. Okay, so this is called as if block. If is assume it to be like a home of if. So home, if has a home, and this is the home. Okay, this home is where you can write the logic to perform what happens if the number is positive. So here I don't want to do any logic now. I'll simply say number is positive. I'll simply say number is positive. Print number is positive. Now again, we have given space here. Okay, why? Because print number is positive is meant to be for if. Okay, only if condition is true, num1 greater than 0, that's when this print should happen. Otherwise print should not happen. So we have to give this within if block. If I take it to main, okay, that is part of main, it will execute irrespective of the given condition. No, we don't want to print at least this line without checking the condition. So we'll check if number is less than or greater than 0. That's when you say number is positive. Okay, so we have to give space. Yeah, sorry, was there a question?
I was saying I got it.
Okay, great. Now one more thing I have to remember here is the number of spaces that we give. For Python, even one space is good. Okay, even if you give one space, it is good. But what happens is, sometimes we might overlook this. When you're reading somebody else's program, you might overlook, and it might feel as if this is starting from the beginning, okay, not part of if block. So, we generally give one tab spaces. But Python does not restrict the number of spaces you give. You have to give at least one, minimum one, to indicate that print is inside if, correct? But you can choose your number of spaces. You can give 1, 10, 5, 100, 50, doesn't matter. But if you're writing another line of code inside this print, say line 2 for positive. Now, if you are putting something like this, line 2 for positive, it has to begin exactly from same place. So for first line, you have a choice. Okay, first line, you have a choice where you want to start, whether you want to start with one single space or one tab space or two tab spaces or three tab spaces, doesn't matter. Okay, you can choose. But once you choose that for line number 1, same number of spaces you have to give for all the other statements. same number of spaces you have to give for all the other statements. Okay, so first line you have a choice. You give 1 space or 50 spaces, you have a choice. But from second statement onwards, you have no choice. You have to start from there. Okay, now I'm going to print one more thing called as thank you, let's say. Now thank you is not inside if because I'm starting from very first position. So thank you is not inside if. So if I run it, okay, so it says number is positive, num2, line 2 for positive and thank you because I gave num1 as 50. Now if I make this as minus 50, then what happens? Okay.
It'll change because it's not greater than 0.
Exactly. Okay. Since it is not greater than 0, these lines of code will never ever get called. That because num2 greater than 0 is resulting as false. Is num1 not num2? Num1 greater than 0? Answer is no. Num1 is minus 50. It is less than 0. So if it is less than 0, okay, that condition becomes false and you will never ever go inside if, and those two lines of code will never get called. Will never get called. Okay, so directly you see the thank you is getting printed because that's anyway part of the main program. So it will anyway get printed. Okay, so this is how we use condition. I need 10 more minutes, okay, and then we'll wrap up for the day. Okay, now here you see if value is less than 0, then we are not handling it. Okay, we're not handling it, right? We're only handling if we're only worried about if number is more than 0, we say this. But let's say, we have something else for if number is less than or equal to 0. Okay, if this condition becomes false, then what to do? So every if, okay, now if you need only one condition to check here, I just need to know if it is greater than 0 or not. That's all. I don't want to do anything if it is less than 0. If it is greater than 0, I want to display positive number. But I don't have any plans to use if number is less than 0. I have no plans to handle it if it is less than 0. So if I have no plans to handle, I didn't use anything. But now I have some plans. If it is not true, if this is false, if line number 65 is false, then it will come to else automatically. So either if or else will be called, not both or not none. Okay, it's not possible to not execute both of these or none of these. Okay, if you have if else, okay, if condition is true, if block will be called and else will not be called. And if condition is false, if condition is false, then this will not be called and this will be called anyways. So I'm going to say print number is not positive. Okay, number is not positive. Okay, so when you have two conditions to check, okay, we use if else. Okay, now see here, number is not positive is fine, but number could be negative or 0, right? So here we need 3 conditions. 2 is not enough, 2 is not sufficient. 2 is telling whether it's positive or not, but it could be positive, negative or 0. So in fact, we are looking at, okay, 3 conditions. So what Python says is, if you have only one condition to check, you use only if. You use only if. If you have 2 conditions to check, you use if else. If you have 2 conditions to check, you use if else. And if you have 3 conditions to check, okay, or more than 2 in fact, okay, more than 2, your first one has to be if and your last one has to be else. In between, you can have any number of elifs.
So I have to start with if and end with else.
Exactly. Okay, Now let's talk about this situation where we have three conditions to handle: positive, negative, and zero. So what I'll do is here, as I said, we have three conditions. So first and last will be if and else. In between, I'm going to add what is called as else if. Elif. Elif is short form for else if. Okay, else, and then you say if num, okay, else if num less than 0, if num is num1, right? Not num, sorry, it is num1. So if num1 is less than 0, you say okay, number is negative. Okay, line 2 for negative. Here I'm going to say line 2 for negative. And then definitely else means what? Else is like default, okay? So if greater than 0, you say positive. If less than 0, you say negative. And else would be number is neither positive nor negative. Okay, number is neither positive nor negative. Let's run this and see if our objective is met. Number is -50, so it should say number is negative, line 2 for negative. Okay, and if I remove minus, it becomes positive, number is positive, right? So okay, this condition has become true. If this has become true, none of these will be even called or checked. Okay, now what if you remove 5 also, and when you run it, okay, you get
Gotcha.
right. Yeah. Yes, so this is how we perform condition check. We'll stop here. We'll continue, of course, tomorrow when we meet. We'll continue and we will discuss about how to handle more conditions. We'll take a couple of examples more and then we'll talk about loops. Any questions before we wrap up?
Well, I think I got that part for the most part. I do got one question for you. Like
Yeah.
as far as your like not having to do nothing with the class, but as far as like communication, do you use WhatsApp for communication? Because I know sometimes I don't be on